Hello and welcome to CompuScholar's Professional Development Series. This is our monthly webinar for December 2018, and this month we're going to talk about using a debugger effectively. My name is Chris Just. I'm the president of CompuScholar. I've spent quite a few years as a software engineer, as well as many years in the education space as well. I'm always happy to answer your questions. You're welcome to send me an email at chris.just@compuscholar.com. So today we're going to start by talking about what debuggers can do and when you should use them, and then we'll switch into some hands-on demonstration using both Visual Studio and Eclipse, which are two popular IDEs. So big picture, a debugger is a tool that is built into a development environment or into the language itself, and a debugger has many features that will help you find and fix problems in your code. With a debugger you can observe a program as it runs and step through it line by line. You can also set a breakpoint that will halt the program at a particular spot if you think there's something suspicious going on in that area. And you can also use the debugger to inspect a variable when the program is in a break state, look at the value in that variable, and even modify it. And that way you can see how the program responds to different types of data. So debuggers are definitely tools that will find runtime errors. These are not tools that will find syntax errors before the program runs, but they will find a variety of things while the program is running. So if your student has written code that has a logical error, such as a loop that doesn't flow correctly, or if then else expressions that don't seem to work quite right, that's a great thing to find with the debugger. You can also, as I mentioned, look at the values in variables to find data errors. So if a variable has some unexpected contents, or a calculation doesn't go quite right, you can inspect the data in the variables and see what's going on there. And then if you get a runtime exception, such as a null pointer reference or a divide by zero or something like that, you can rapidly home in on the exact line of code that is causing the problem, and then kind of look backwards to see, how exactly did you get to that state. So what we really want to try and promote is the fact that a debugger should really be a student's best friend. We are approached all the time by students with questions on their code, and usually when we ask them to give us some insight as to what they found when they used the debugger to step through the program, we get these blank looks back like they've never heard of a debugger. We do have debugging chapters in each one of our courses because we think it's a very important skill, but unless you do reinforce that with the students, a debugger could be something that they use maybe once when they're forced to, and then they rely on other techniques to try and find errors later on. So once a student has learned about a debugger, you definitely want to reinforce usage of that throughout the remainder of the course. So anytime a student has a runtime error where they're not sure why a program is behaving incorrectly, a lot of times your first response should be, hey, give that a try in the debugger, set a breakpoint, step through it line by line, and see if you can't figure out what's going on that way. Sometimes that's just the easiest way to do it, as opposed to staring at the code or adding in a lot of trace statements. Okay, we're going to briefly demonstrate how to use debuggers in a couple of different development environments. We're going to use Visual Studio with a C# example, and then Eclipse with a Java example. And of course, if you're using another IDE or another language, they all work pretty much the same way with the same set of features and the same concepts. Okay, we're looking at Visual Studio, and I've created a simple project here called Temperature Converter with the goal of converting temperatures from Fahrenheit to Celsius or Celsius to Fahrenheit. So what should happen if the user types an entry into the box here and clicks the 2 Celsius button is it will read that Fahrenheit value and convert it to Celsius and display that in the message box. And then vice versa down here, if the user types in a Celsius reading in the Celsius box, clicks the 2 Fahrenheit button, then the Fahrenheit temperature should be displayed. Now if we look at the code, I've kind of blown it up here so hopefully it's easy to see in the video. When the Celsius button is clicked, or the 2 Celsius button is clicked, we'll read the Fahrenheit temperature, call this Fahrenheit the Celsius function, and show a message box with the results. And then here's the actual conversion function. The conversion itself is very simple, but I've deliberately put it in a function so we can practice stepping into a function. And then when the Fahrenheit button is clicked, similarly we'll read the Celsius value, call this Celsius to Fahrenheit function, and then show the results. So of course there's a couple of hidden errors in this function, so let's go ahead and run it and see what happens. Now in Visual Studio, your default setting usually is debug, so there's actually nothing you have to do to really engage the debugger. Just go ahead and click on the Start button, and if you're in the debug configuration, the debugger will automatically be launched. Okay, here's my form. Let's go ahead and try a Fahrenheit conversion. So if we type in 212 degrees Fahrenheit, we would expect that to be converted to 100 degrees Celsius. Uh-oh, there's a problem. So the system is showing us a runtime exception. So in the debugger, you can see we're actually in a break state here at this particular point. We are right where the error occurred, and the program is frozen or paused at this point. And it will tell us there's something wrong with the input string, there's not in a correct format. And as I mentioned, you can actually look at the values in the variables. So if I hover over this Fahrenheit string variable, you can see a little tooltip pop up that shows me that's an empty string, which is bad news. You can also look down here, there's a window that shows the variables automatically, and you can see the Fahrenheit string as well has these empty double quotes. So there's nothing in the Fahrenheit string. That's obviously a problem. We need to figure out how that happened. So what we're going to do is let's just stop the debugger. Debug, stop. And we're going to come up here to where the function was called. And I've just clicked over here in this left-hand column. So you can see a red circle. That's a breakpoint. So a breakpoint is a spot where if you are running in the debugger, the program will automatically halt at that point and show you the line of code that's about to execute, and you can look at the variables and so forth and see what's going on. Let's go ahead and start it again. And we'll type in our 212 degrees Fahrenheit. Click the button. Okay, so we're now at a breakpoint. We've hit our breakpoint. You can see this line of yellow is the line that is about to be executed. It has not been executed yet. And it's going to call this Fahrenheit to Celsius function. And again, you can hover your mouse over this variable here, and you can see even at this point the variable is empty. So what you want to do is start looking backwards in your code to see what's going on. Where is this variable supposed to be initialized? Well, it's initialized on this previous statement, and we can see it's initialized by reading the text box text field. And there's something a little odd here because this text box itself has an empty value. So we know we typed a value into that text box. So what's going on? With a little bit of thought, we can see we're actually reading the wrong text box here. We wanted to read the Fahrenheit value, not the Celsius value. So we have simply written code that compiled fine because it's not a compile time error, but there's a runtime error here. We're just reading the value out of the wrong text box. So let's stop our program again and fix that problem. I'm going to go ahead and replace the text box name. So now we're reading the value out of the correct text box, and we could go ahead and start it again. One more time with 212 and click the button. We're at our breakpoint. We can hover over this variable and we see the tooltip pop up. Now we're 212. So this is great news. We fixed the immediate problem and we're feeling pretty confident. If you want to, you can still step through the program line by line, and there's buttons up here that will let you do that. So step over will actually step over the entire function there and just execute the entire function as a single step. So if you're confident that that function works correctly, you can step over. You can also step into, which means you actually want to transfer it into the function and watch that function run line by line. So let's do that. We're now stepping into this function, and we can step over it line by line, watching things happen. We can look at the Fahrenheit string here, see that it's 212, double check that the double value is correctly parsed out. Step over the calculation to see our Celsius temperature is 100, which is what we expected. And then once we're confident, let's just go ahead and click the continue button to let the program run. Okay, great. The temperature in Celsius is 100. That's what we expected, so this is now working correctly. Let's go ahead and try the other side. So if we type in 100, we would expect to go back to 212. Okay, so the result that we got was 148, so clearly there's something wrong here still, but we didn't get any exceptions that pointed us directly at the line of code, so we need to do a little bit more sleuthing. We can go back to our program. Let's put in another breakpoint here at the point where this button is clicked, and then we'll just step through it to see what's going on. Okay, so we click the button again, we hit our breakpoint, and let's just step through it and verify what's going on. The Celsius string was read out correctly. Looks like we're calling the correct function. Let's step into that. Step, 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 step. Our Celsius temperature is 100. That looks good. Let's step over the calculation. So with a 100 Celsius temperature, the resulting Fahrenheit seems to be 148. So we know this value is correct, this value is wrong. So something has clearly gone wrong on this particular line. And if we go back to our original program requirements or do a little bit of research, we'll see that this math symbol here is actually wrong. That should be a plus instead of a negative sign. So let's stop and fix that problem. Make that a plus and then run it one last time. Okay, we'll type in our 100, click to Fahrenheit, and since we think we fixed the problem, I'm just going to take this breakpoint out so it will run to completion. Great, now we're getting 212 degrees Fahrenheit, so we fixed the problem in the code. So this is the Visual Studio debugger. It has breakpoints, it has ways to step over code, to step into functions, to inspect the variable contents, and we can actually do the same thing in Eclipse. So let's switch over and I'll show you that very briefly now. Okay, we're now in Eclipse, and we have a very simple temperature converter program that has basically the same sort of functionality. It's not a graphical program, it does things here on the command line. So it's going to ask the user for a temperature in Fahrenheit and then call a function and so on. So we already know there's going to be problems in this code, so let me go ahead and just click over here. I'm going to double click. There's a tiny blue circle. Hopefully you can see it in the video that represents the breakpoint. So let's go ahead and run. So in Eclipse, you're not going to run in the debugger by default, but you can click on the little creepy crawly here. This is the debug option. Let's click on that to start in the debugger. Okay, after I've started it, you can see we have hit the breakpoint here with the next line that's about to execute highlighted in green. You can see a panel up here to the right that shows all sorts of variables and the variable contents. And across the top, we've got a toolbar with similar features. You can step over, you can step into, you can stop the entire debugger, you can run to completion and that sort of thing. So let's just step over, and it's going to prompt me for this temperature, 212. Alright, so now we're on the next line, and we'll just step, and we hit an exception here. So somewhere in that function we hit that exception, and again it's very similar to what happened before in the earlier program. I'm not going to go through the whole exercise of elaborately fixing it. Let me just leap right to the problem here. And the temp that we want to pass in is actually stored in this temp variable. There's nothing in Fahrenheit temp, so that was the root problem there. So we can go ahead and run it again. Click the little creepy crawly button here, and we'll step, enter our temperature, 212, step, and it'll print out the correct temperature. So great, we fixed the first problem. I'm going to step right on through to the next one where it's asking for a temperature in Celsius. Let's enter 100, and step, and it's printing out 148 again. So we had the same problem with a math error. You could step into the function, find that error, and do everything kind of the same way that we did in Visual Studio. So I just wanted to show you Eclipse because it is very popular, and if you're using some alternate IDE, whether it's for Java or some other language, then you'll certainly have a very similar set of features. Okay, so that was a whirlwind tour of debuggers. We do definitely encourage you to work with your students in the debugger to make sure that your students are comfortable with the debugger. If you have any questions about what they can do and how to use them, always happy to answer those questions. Again, you can email me directly at chris.ust@compuscholar.com, or you can contact us through our website. Thanks for watching.